I want to start this talk with this scene from Rick and Morty, but just before starting, can I see a show of hands who are familiar with the show or not? Okay, yeah. So just for you who doesn't know, it's not mandatory to know the show. So on the left here we have Morty. Morty is in love with Jessica. Jessica doesn't care about Morty. So Morty goes to his uncle Rick, whom is this genius scientist who can solve everything with science. And so Rick comes up with this love potion. He gives it to Morty. Morty goes to a party, makes Jessica drink it, and it works. Jessica is in love with Morty, but the fallback here is that Jessica had the flu, and then it spread across the party, and now all the party and the whole city is just crazy about Morty. Morty goes back to his uncle, and then Rick come up with a new solution, and they spread across the city. It doesn't work. And now all the humans just turns into monsters, and the whole city is just chaotic and chaos, and they cannot reverse the changes. And so they just have to ditch the universe they're living in and go to another parallel universe and start living there. And so Morty is traumatized. Yeah. It reminds me of our last Friday production hotfix. So I want you to take a couple of seconds just to look at Morty's face and see if it's familiar to you. Like, have you seen it anywhere? So basically, it's this look. I mean, I saw this look many times working in tech. It's the look of a data scientist when they're working on their model for weeks. They put it into an A/B test. It fails the A/B test. It's the look of a product manager when their feature or improvement just causes the revenue to fall. And it's the same problem that Rick and Morty have fallen into. It's this problem of when you're trying to solve something, but without considering the whole system, right? So let's take a step back here and see what happened. So Rick did come up with a solution, which is this love potion, but he only considered the input at hand. He didn't consider the city, the flu, the whole system. And normally in real life, like you would have, let's consider this diagram on the left. Let's say this is a working system. It can be anything. We will notice that C is not doing very well, so we want to optimize C. And let's consider that C is a machine learning model, just for the sake of this talk. And so we got a data scientist. The data scientist takes the C, do some machine learning magic, come up with C v2. It might be improved C, like an improved model or another model. We take C, we put it in the system. Now E is green, so everything is good. But we broke D. Why? Because D also take input from F, which we didn't know about, and now G is also broken. And this problem, once you start see it, you see it everywhere. Like the problem when you're trying to optimize, is the problem of local optimization. You optimize something, when you put it in a bigger system, it fails. It's everywhere. It's in backend, it's in product, it's in machine learning, and it's even in your real life. Like you're doing some recipe, you're following some recipe, you taste the stock, it needs some salt, you add salt, it's good. Later in the recipe, you need to add soy sauce. And now everything is just too salty. Sorry for the long introduction. My name is Abdullah Taha. I work as an MLOps engineer at Zalando. And today I'm going to talk to you about this exact problem of how to optimize holistically, how to optimize a pipeline. And we're going to focus today on the problem of HPO, of hyperparameter optimization, and how we at Zalando implemented a solution, a scalable solution with Ray and cloud infrastructure. So just to give you a little bit of content, I'm going to start with some context and what we do at my team at Zalando, and how are we dealing with hundreds of machine learning models in production, just to give you a background of where are we starting from. Then we're going to narrow down a little bit on the problem of how to optimize a pipeline. Then I'm going to present you with the solution design that we did, how do you implement. Like we tried a couple of POCs, a couple of implementations using Ray and cloud infrastructure. And then I'm going to show you some comparisons and some insights that you can take home. OK, let's start. So I work at a forecasting team at Zalando. And our team is responsible for predicting a couple of business KPIs, like number of sold items, cancellation rate, et cetera. Predicting those targets helped Zalando to plan some logistics, to plan budget, et cetera. And we do this for 24 countries, roughly. And like each of those boxes is not a single machine learning model, but it looks something like this. So we might have like model 1 is a short horizon model to predict like 5 weeks of data. We have like model 2 that would predict like 15 weeks of data, a long horizon model. Then we might have like an ensembler that take the input from the models and do some ensembling techniques or so. Then we would have like a post-processor and the KPI consolidator that take the input from another KPI and try to make result consistent. So yeah, it's kind of pipeline, and then we get the final target. So if you try to visualize this for each of those KPIs multiplied by 24, you would understand that we're dealing with kind of hundreds of models. So how are we doing this in production? We are following a config-based approach, kind of. So you see here, this blue library is like we have a library that holds every machine learning codes. So it's training, evaluation, splitting, post-processing, whatever. And this library is used by configs. So normally a data scientist just try different configs to experiment with different machine learning models. And then whenever he gets the best model or the best config, he would just give the config to the MLOps, which is me. I put it into production, and I take my salary. Even that, like I give it to Claude now, but yeah. And for the dependency here, you see that we have some kind of DAG. Like here we have dependencies. Like it's a kind of direct acyclic graph. For the dependency management of the DAG building, we use Airflow. We also follow a config-based approach there. If you watch the talk by Akif, he talked that this is a good design. So we also have, like we define the dependency there in kind of config, and then we have a dynamically generated DAG in Airflow. This part on the right is our production, but we're going to focus today about experimentation part. So normally when a data scientist wants to experiment with machine learning model, he would use this process called hyperparameter tuning or hyperparameter optimization. I'm sure most of you are familiar with the topic, but just an overview. Wow, this resolution is bad. Okay. So you start with ML model. You start with a machine learning model. You define a set of parameters that you want to optimize, and then a search space is created. So this search space is basically like a combination of different parameters that you want to optimize against. And then the hyperparameter tuning happens. I will talk a little bit more on that. And then you get the best configs of your model. And the hyperparameter tuning looks something like this. So there's a couple of approaches to this, but yeah, just an example. We're talking here about the Bayesian optimization. So you would have an optimizer. The optimizer creates the search space. And then the optimizer decides on an initial set of hyperparameters. And then you would trigger like a couple of trials. On each trial, you would train the model, evaluate the model, and then the result would be reported back to the optimizer. After a couple of iterations, you get your best results. So looping back on our problem, if you recall this picture from before, so basically in the normal circumstances, you would optimize, model 1 for the output of model 1, which we don't want. What we really want is that we want to optimize model 1 for the output of the pipeline. And not only that, we want to optimize each step of the pipeline. Like we want to optimize the parameters at the ensembler, the parameters at the post-processor, et cetera, et cetera. And so if you like this diagram that I showed before about the hyperparameter optimization, what we really want here for each trial that we try, we don't want to try training only the machine learning model. What we want to do is this, basically. Now, this is the core of this presentation. This is what we want to implement. We want for each trial to evaluate the whole pipeline. Okay, so how did we do this? Like every good engineering team, we go and consult our senior principal data engineer. No, just joking. So how did we do this? Well, we used Ray. And for those of you who doesn't know, Ray is a very cool library, a machine learning library that allows you to run machine learning in a distributed way. So you would write the same code. It would run on your either machine or run on like 10 machine cluster, and it's the same code. So we used Ray as the main implementation library, and for the infrastructure, for where the code would be executed in a scalable way, we tried a couple of POCs. One on SageMaker, one on Databricks, and we also tried our own custom solution running array cluster on EC2s. So from Ray, we used the HyperOpt search model, which is a component under the Ray tune. So Ray have a couple of libraries, one for training, one for data processing, et cetera, et cetera. So this one is under the Ray tune library. And this diagram is from the documentation of Ray. And as we talked before, as like a hyperparameter tuner, you have a search space. And here you trigger the trainable. So the trainable here is the objective function that we want to tune against. So normally this is a machine learning model. But what we will do is that we will use this customizable component to feed a pipeline into this. And so this is just an example from our code base. So here, when we define the trainables, we take, like we tried a couple of POCs, so this is just a dictionary of those. As you see here, when we define tuner, we pass the trainable. So here, like each of those functions are responsible of building a pipeline. And I will talk a little bit more on that. So just to give you a rough idea, this is the config that a data scientist might write. So without going a lot into details, you can see that we have steps. And under steps, we have 3 steps basically here. The naive seasonal, which is a model. We define the name of the model, the class that it will bind to. And then we would define the parameters that we will optimize. And like here, we have another model, which is auto ETS. And here we have an assembler that would take as input the 2 models. So here we have the structure of how the pipeline, which is a very simple pipeline here. But just to give you an idea. Now, in terms of solution design, here we need 2 components, basically in the solution. One, which is the entry point. So here, where the data scientist would interact with this whole system. So the data scientist would write those configs, and then what? He needs to put them somewhere. And so this entry point is where data scientists would just define the configs, define the class that we wrote, and then trigger whatever method it's working. And what is triggered, basically, so the infrastructure should be able to build this concept of a DAG, or this concept of pipeline. It should run multiple trials in a scalable way, and it should report back to the entry point. So this is just an overview of the solution. So we tried a couple of POCs. As I mentioned before, I will talk a little bit on details on those. We tried on SageMaker, on Databricks, and on EC2 machines. There are two worth mentioning things that we didn't try, but if I have time, I will talk a little bit more. So what are the considerations when we will build such POCs? There are a couple. So there are performance. So each infrastructure here has its own boot time, running performance, maintainability. How hard does it? Do you need engineers to maintain your environment, or is it self-maintainable? Like you can imagine that building custom thing would require more maintainability. Usability, does the data scientists are able to use this easily? Traceability, where can you see logs? Where can you see failed step, failed pipeline? Cost, limits of the infra, etc. Okay, let's start. So we start with the SageMaker POC. So in SageMaker, we use this concept of SageMaker pipelines. If you're not familiar with it, so you can define multiple training jobs and you can bind them together, and it's called SageMaker pipeline. So as our entry point, we used SageMaker Studio notebook. So the data scientist would log into SageMaker Studio, open a Jupyter notebook, define the configs, trigger the system, like define the class and run the cell. And then in the background, it would use the config, use SageMaker pipelines to build a DAG and run each trial on a single SageMaker pipeline, basically. So you would run this in a scalable way. And this is some code. So here, as you see, for step-in-step configs, we're iterating over each step. And in each step, we're doing define job training. So we're defining a SageMaker training job. So this is one step of it. So we're defining multiple jobs. And then in the second for loop, we're looping over the dependencies between the steps, so we can bind them together. So when you use this, basically you create this DAG. And then, and then you return the pipeline, and this Ray would use to evaluate against. And this is a screenshot from SageMaker. As you can see, there are 2 steps, and there are bounds into this ensembler step. It has nice UI. You can see the running steps. You can see the queued steps. And if, here in SageMaker, if you want to see logs, they are all go to CloudWatch, if you are familiar with the AWS ecosystem, tech system. And if you want to also look for each instance CPU and memory usage, you would also go to CloudWatch. So another similar one, which is Databricks. Databricks also have this concept of pipeline, which is called workflows. Again, same system. Here for the entry point, I'm going to skip that part because it's not very important. It has a similar, just to keep the timekeeping, it has a similar concepts, and it has like this nice visual UI. And in Databricks, I think it's very nice that they have this airflow kind of look. So you can see a couple of like running pipelines. You can see the logs directly from there. You can restart each step. Like if you have failed step, you could look at log, or you could try a retry, which isn't there in SageMaker. And so yeah. Now the third POC that we tried, one thing to note about the first POC is that here we didn't use Ray cluster. We basically used Ray library, and we did the scalability on ourselves. Like we tricked Ray to triggering each SageMaker pipeline or each Databricks workflow. So we provide scalability in this way. But in this one, we use basically Ray cluster. So as an entry point, we use, again, SageMaker Notebook, but it can be your local, it can be anywhere. Here, we spinned up a Ray cluster. So we said, OK, I want a 5-machine EC2 cluster on spin it up for me. And after that, we're reading the configs and submitting the job to Ray. And then Ray would use those machines to run this in parallel. And if you recall, we needed something to define this DAG. And here, we used Metaflow, because we need, if you're familiar with Metaflow, you can build Python classes, and you can build a DAG from the classes, basically. So yeah, this is a little bit more complex, but it's without using a platform. We needed something to measure against. Two just worth mentioning things. I'm not going to spend a lot of time. So Databricks also have this concept of Ray cluster inside Databricks. So you can run one notebook, run a Ray cluster behind those notebook. We didn't try this, but basically, like, one downside here is that you cannot see the pipelines running behind the notebook, because you have one notebook and a lot of things running in the background. Another thing is this platform, which is called Anyscale. So this is a platform that's built by the people who built Ray. First, they built the library. They said, OK, we built the library. Now we built the infra. So they basically request to connect to your AWS system, and they would handle like spinning up the machine, terminating the machine, et cetera, et cetera. And they give you this nice notebook kind of thing, and you can run things, and it will just scale by itself. So some comparisons. So in terms of spin time and wormhole, let's start with that. So each of SageMaker and Databricks have this concept of wormholes that you can, don't need to wait for machines to boot up. On Ray on EC2, this can be configured. We can just spin up Ray cluster beforehand, and so we would kind of configure that. In terms of traceability, monitoring, debugging, so where to see the logs, how to trace the pipelines, I think Databricks have the nicer UI in terms of this. On Ray on EC2, it's none. It's basically a terminal, but it can be configured again. So yeah, let me just a quick insight, like here, Ray on EC2 is the most configurable one, but it requires more maintainability. You need an engineering team to maintain this. The other one is a little bit, OK, you pay more for a platform, but you get better, less maintainability. OK, final thoughts. So what's the winner POC between those? None, obviously. I mean, we ended up using SageMaker just because our data scientists were just using SageMaker from day to day. And it really depends on your requirement. If you require to more configurable thing, you want to publish logs to some other platform or so, you can build your own stuff. If you don't have engineers, and like one engineer and like 50 data scientists, you probably don't want to build something custom. And again, like the second insight is your ML infra is only as good as the ability of data science to navigate it. You can build the most amazing system, engineered system. If the data scientist cannot use it, it's useless. The third one is go look around. I mean, take the local optimization problem in your system. Try to figure out the solution. Don't be a rick. I mean, the insight here is that we talked about this concept in the context of hyperparameter optimization, but this problem is everywhere. It's on all products, back in engineering. You're trying, yeah, just go around, try looking for it. The fourth insight, well, yeah, I needed to fill out the template and I didn't have the time, so, okay. I wanted to finish with this quote from a great author in system design. The performance of a system is not the sum of performance of its parts, it is the product of their interactions. Thank you very much. And if you're interested in the talk, if you like the talk, if you want to work on this similar problems, please join us at Zalando. You can look at our open jobs at jobs.zalando.com. If you want to reach out to me through LinkedIn, you can use the link on the right. Thank you very much.
Okay, thank you so much. First question is, when testing the POCs, did you use enterprise level or were the tests using the open source levels of different POCs?
I mean, in Zalando, we all have both Databricks and SageMaker are used at an enterprise level, so it's not open source free stuff, no.
Any more questions, anyone? Do you have anything to say?
That's bad. Okay.
Thank you so much. We can give him a big round of applause.